This is video 12 for geometry, kind of part 2 of transformations. We're going to be talking about rotations and symmetry. So getting started, looking at rotations, it turns a figure around a fixed point, and that fixed point is called the center of rotation. So here in this picture, our fixed point would be P. So we take image DEFG and rotate it to its new image. Okay, and a lot of times we called this a turn when we were younger. And the pre-image and the image vertices are the same distance from the center of rotation. So G and G prime are the same distance from this point P. Now the angle of rotation is formed by a point in the pre-image and corresponding image point, and to find that angle. So a lot of times we rotate things at 90 degrees or 100 degrees or 180, 270. So that would be our angle of rotation. And then the last part for rotating is we always rotate counterclockwise unless we're told otherwise. So counterclockwise we go that direction. So we always go that direction unless told otherwise. All right, so we've got some rules for some rotations that will help you when graphing some of these things. So if we have a 90-degree rotation, our point from XY changes to negative Y, X. Okay, and this is kind of a cheat sheet of how to graph some of these things. 180 points stay in the same order, we just make them both negative, and 270 is kind of the opposite of 90. And that's how we change our points. So let's do an example. We're going to be rotating this figure 90 degrees. So my point 1, 1, I'm going to be looking at my 90 degrees. I'm going to flip-flop my points, and my Y value would become negative. All right, 2, 3, I'm going to flip-flop them, and my Y value becomes negative. So it'd be negative 3, 2. And our last one would be negative 1, 5. All right, so let's go ahead and graph this. Our A would be over 1 up 1. So this would be A prime, B prime. All right, negative 3, 2. And C prime, over negative 1 up 5. And so that's rotating that triangle 90 degrees. Okay, very briefly I want to talk about composition of transformations. When you look at them, make sure that you do them in the order that is in the direction. So if it says rotate 90 degrees and then flip over the x-axis, make sure you do that in the correct order. We're not going to have any examples of those because it's just all of them kind of added up together. But I want to talk about symmetry. A figure has symmetry if there's a transformation such that the image and pre-image touch. Okay. Looking at line of symmetry, or that is called reflection symmetry. Okay, and it's reflected across a line so that the image coincides with the pre-image. So a heart, I can draw that line of symmetry right down the middle. If I fold that in half, it's going to be the exact same. Looking at our triangle, line of symmetry, again, is right down the middle. Now when we have a square, we have tons of different lines of symmetry. And this is where it kind of gets fun. We could have one going down the center. We could have it going the opposite direction down the center. We could go on the diagonals. Okay, and so it's really fun to do symmetry when we've got more than one line of symmetry. And then rotational symmetry is sometimes called radial symmetry. And it's when we can rotate it more than 0 but less than 360 degrees, and it's going to look the same. So like if we look at a square, if I rotate this 90 degrees, it's going to look the exact same. If I rotate it again 90 more degrees, it's going to look the exact same. It's still going to look like a square. Now I couldn't do that with my heart. If I rotated my heart 90 degrees, my heart would be facing towards the left. Okay, so it doesn't work for everything. But if we look at this shape, if I rotate this 180, it's going to look the exact same. It's still going to be this kind of ZL shape. All right, and then my snowflake. Well, I could rotate this about every 45 degrees, and this would be the exact same thing. So I can rotate it no matter what. If I rotate, it's still going to look the same no matter how I rotate it, because it's the exact same. So I wanted to look at a couple examples. Looking at this, this could be a reflection of each other. If I fold this paper in half, these would be a reflection of each other. Here we have a rotation. Okay, I'm rotating from this guy, and I'm rotating around my fixed point up here. All right, this one it could be a translation, how I'm going sliding over, up some. Okay, and a lot of these are just reflections of each other. The star is a reflection of each other. The sea. Okay, so I just wanted to give you some examples of what rotations and symmetries can look like. All right. So that was kind of a quick video going over symmetry, rotational and reflectional symmetry, and then talking about just rotations in general.